Unit 4, BMATH 048. Well, um, in Unit 4, measures of center, we're going to study two ways that we can um, talk about this. One is the mean, and the other is the median. Now, in the unit, there is a video that you need to watch before you start the unit. And this video is located in the Moodle course. It's about 9 minutes long, and it really pulls it together for you. You need to be watching this video for each unit that we do. In the video, the weekly wages of men and women are compared in using histograms. And the shape of the histogram will determine whether or not the mean and median really are in close agreement. If you have a very symmetrical histogram, then the mean and the median will be pretty much the same. However, if the histogram is skewed, the mean will be sort of pulled in the direction of the tail. And the mean in that case might not really be a good measure of center. So on this histogram, values out here can have a disproportionate effect on the mean. The values out at the tail end, because you could just have a few people, say, talking wages, with very high salaries, and those few people with really high salaries can really pull out the mean in the direction of the tail. So there's an example given in the video where there's some small hypothetical company, got 19 employees, and you want to find the average salary of the employees. So what you do is you add up all of the terms, all the wages, I guess these are weekly wages, for these employees in this small company. So you add up all the wages, and then you get some number, and you divide that number by the number of things you've added up. So that's given by this formula. Now, in this formula, X bar means the mean. So that symbol, an X with a bar over top of it, is the mean of our distribution of values. The summation sign, summation X, this means add up all the terms. And N is the number of terms. So this is how you find the mean of a distribution. Now, something I will say that wasn't really emphasized in the video is that you need to rank your data. It doesn't matter for the mean. Now, when I say rank the data, the smallest value in this distribution of data is 290. The largest value is 2000. And all of these numbers are all ranked, meaning they're getting larger. Each number to the right of its neighbor is a bit larger. So it's important to do that. It's essential to do that. It's critical to do that when you're calculating the median. It doesn't matter for the mean because you can add up numbers in any order and then divide by the number of terms and you'll have the mean. But it's essential for the median, and also not essential, but it helps for the mode to be able to recognize when you have repetitions of a particular value. Now, so once again, this summation sign, that means add up all the terms. And then there's an example here of what they've done. They've added up all the terms and then divided by the number of terms, which was 19. Now, the median is the middle value in the distribution, and they talk about that in the video. So if you have 19 terms, such as in the video, you'll have a median, your middle term, will be just like one number. So odd number of terms, the middle term will be given by the formula n plus 1 divided by 2. And the number you get out of here is the location of the median. Just to be clear, it's not the actual value of the median, it's just where the median is in the ranking. Now, if you have an even number of terms, the formula still gives you the location, kind of the median, but what you need to do is you have to take an average of the two terms on either side. So, for example, it's going to be the average of the two terms bracketing the number you get. So, average is the average of the rank of the two terms on either side of the median. To just recap, here's a distribution that is symmetrical, and the median is very similar to the mean because it's a symmetrical distribution. Here is another distribution where the mean is bigger than the median, and that's because you've got a lot of, I guess I wouldn't call them outliers, but values in the ranking that have high scores, and that sort of impacts the balance of your distribution, pulling your mean out towards the tail of the distribution. In a similar way, if you have a non-symmetrical distribution where you've got it's skewed, then this distribution skewed to the left, then the mean is less than the median. There's the mean. There's the median. The mean is less than the median because these scores here have more impact on the average, otherwise known as the mean. So this is in your online notes, calculating the median of distribution. This is the most important thing to start with right here. Arrange the observations from smallest to largest, and then you can just sort of read the rest of the instructions what to do there. And another example for calculating the mean is given as in the notes. So you can read that. And there's a histogram, again, of the exam scores used as an example in the notes. You can see that the histogram is skewed, and so that the mean will not match up closely with the median. And they talk about that in the notes. So there's some key terms, median, it's a midpoint of a set of data, and then you've got the formula for calculating the average or the mean. So the unit activity. So I'm going to do a demonstration of how you access this. So one of the things you need to do is to access stem plots from the interactive tools menu. So you do that in your Moodle course because there's a direct link to the tools for working with statistics in Moodle. So you've used the stem plots, plot your data mode tool. What I want you to do now is get into quiz yourself mode. And what I'm going to do is generate a new stem plot. So I've got my number of observations set to 10, and I'm going to generate the stem plot. This is just the instructions that are given in the unit activity. So now I have a stem plot, and I've got a list of scores. You'll notice that these scores are not ranked. I need to actually rank them manually. Well, the easiest way for me to do this is to just use visually the stem plot. So the lowest score is 7, and in fact, there's 2 of them. And after that, there's a score of 10, and then a score of 24. I'm going to write these scores down in order and then use that information to calculate the median. And then I will work to calculate the mean. I will then put my values in and see how they compare to the answers generated by the software. So here's my data, here's my stem plot. And what I'm going to do is I'm going to start writing down the numbers and rank them. So I'm starting with a 7, and then there's another 7, there's 10, there's a 24, and then there's a 31, 33, etc. I'm just going to add write them down. So to calculate the mean, I take all these scores and I add them up. The total is 411. I then take the total and divide it by the number of terms, which was 10 from my histogram. So the mean turns out to be 41.1. So the mean is there somewhere. Okay, that's the mean. So the median, however, is handled differently. The location of the median is found by using the formula n plus 1 divided by 2, where n is the number of terms. So there's 10 terms. 10 plus 1 is 11. 11 divided by 2 is 5.5. That means what I need to do is I need to find the numerical average of the 5th term and the 6th term. The 5th term is, well, in my ranked data, 1, 2, 3, 4, 5. The 5th term is 31. The 6th term is 33. The numerical average of 31 and 33 is 32. So the median will be 31 plus 33 over 2, which is equal to 32. So the median is actually the median 32. I mean, it's down here somewhere. So the median and the mean aren't matching, and that's because the distribution is skewed towards the higher numbers. You got some high terms here, like for calculating your mean. Let me just show you. There's 93. That 93 really has a lot of pull, if you like, on the mean and pulls it up. Right, now I am going to generate a new stem plot, 10 observations. Here we go. And there is another new stem plot. So once again, I'm going to calculate the mean and the median for this stem plot. Looking at the general shape of this, can we make any predictions? Well, I would say again with this stem plot, because it's skewed, it's not symmetrical, we have 2 values that are high, larger than the others. We've got 71 and 74. And I believe what that means is when we calculate the mean is going to be skewed in the direction of the tail down here. The mean will be larger than the median. Let's find out. All right, so I've taken the data from the stem leaf plot and I've ranked the data from smallest to largest. And then I found that the sum of all of these terms was 569. And then I divided that by 10 to give me the mean, which is 56.9. So the mean, 56.9, the mean's in here somewhere. Okay, now I'm going to calculate the median. Well, the median is the middle term in this distribution of data, which I used the histogram to generate. And once again, super important to rank your data from the smallest value to the largest value. Now, the fifth term is given by the number 49. The sixth term is the number 56. Why am I choosing these? Well, when I calculated the median, I took the number of terms and added 1 divided by 2. So the median is somewhere between the fifth and the sixth term. So I identify the fifth term, which is that one. 1, 2, 3, 4, 5. And I identify the sixth term, which is that one. And now what I'm going to do is I'm going to take the average of those two terms. So I'm going to go 49 plus 56 over 2. And that will be the median. Which is 52.5. So the median is 52.5. Now remember my prediction. My prediction was that the mean would be larger than the median because the distribution has a couple of heavyweights down here at this end, like down there. You got a 71 and a 74, and those heavyweights are going to be pulling the mean in their direction. The items at the tail of the distribution, once again, pull the mean in their direction. And the mean is 56.9. The median is 52.5. The mean is bigger than the median. So question 3 in the unit activity is to use the stem plot tool to generate the 17 final exam scores, and then the final exam is worth 150 points. So I'm going to set the maximum observation value to 150. Oh, just as an overcap, what I did was I submitted our calculated mean to the stem plot tool and the calculated median and submitted my answers. And from the message window here, it says that I did it correctly, which is reassuring. Okay, generate new stem plot. Here we go. So we want to have 17 observations, and the maximum value is going to be 150. Okay, generate stem plot. There it is. And now I'm supposed to actually make a prediction based on the shape of the stem plot. Well, looking at this stem plot, to me, this stem plot looks like it's skewed down to the bottom. In other words, there are a lot of values that have high scores. So if this is a test or something where the maximum score is 150, it looks like there were a number of people who did very well. And as a consequence of that, the mean will be skewed in the direction of the tail down here, because these very low scores will have a disproportionate effect on the mean. The median, however, will be a better measure of center. So now I'm going to calculate those. Well, I've taken all the data from the stem leaf plot and I ranked the scores from lowest to highest. There they are. I added up all of the scores and I got a total of 1,360. To get the mean, I take the total and I divide it by the number of terms. Well, there are 17 terms. So the mean turns out to be 80, dead even. 80 is the mean. Okay, now I'm going to calculate the median. Calculating the median, well, I've got to calculate where the middle of this set of data is. So if the data is all ranked from smallest to largest, the number of the term that will be the median is given by the formula n plus 1 over 2. Well, in this case, we have an odd number of terms. So 17 plus 1 is 18, divided by 2 is 9. So I'm going to find the 9th term here. So I'm just going to count down from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, well, I should be able to count from the other direction too. It's middle term. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, look at that. It works both ways, which it should because it's the middle term. So the middle term actually is the term that contains the data value 108. So the median equals 108. Well, I had to make a prediction, and my prediction was that because of the distribution being skewed down to the tail end, that the mean will be pulled more in that direction because of the skewing that's occurring down here. And so these terms down here that contain values like 5 and 8 and 11 and 20, those terms are so far removed from the middle, they're having an undue effect. And what that has done is it has skewed the mean, so the mean shifted in the direction of the tail. And so the mean in this case is less than the median. I will write that using an inequality symbol. So we saw that with 17 final exam scores or 7 data points, you have an odd number of terms. So the median is really easy to find. It's just the middle term. Now, question 4, you can do on your own with a new sample set of 17 final exam scores, because it's just random. Every plot will be different. So you could make a prediction. Will the mean be bigger or smaller than the median, or will it be the same again? Depends if the data is symmetrical or not. Now here's 70 exam scores. And what we're going to do is we're going to copy this information into a Word document and then cut and paste or copy and paste from the Word document into the stem plot tool. So really what you need to do is you need to take the PDF that's in Moodle, save it to a drive, open it up with Word, find question 5 in the Word document, and then what you're going to do is you're going to copy this and then paste this into the stem plot tool. So I'm in Word now with the information. I've got it highlighted, and I'll just have to do that again. Here we go. Got it highlighted, and I'm going to copy it to the stem plot tool. So here we go. Stem plot tool is here. I'm going to put the data in here. There it is. And it can look messy like that. It doesn't matter the way it was in the Word document. There's a bunch of spaces in between, and it's just been pulled into the stem plot tool. So what I'm going to do at this point is I am going to generate a stem plot. There it is. Well, there's my stem plot. Now, if you notice, the mean is given as 54.3 and the median is 61.5. So the median is the middle term. So there's 70 terms, and I'll go over how you're going to calculate those things. But let's just take a look at the shape of the stem plot right now. So you can see there's a great number of terms that have values in the 30s, and a great number of terms that have values in the 60s. What this means is the median isn't really going to give you a good indication of what middle is, because I guess it does still, but I mean it's not that useful. The most useful piece of information that comes out of a stem plot like this is called the mode, and the mode is the most common value in the distribution. So what you do is you'd rank these values. So the smallest value is 32. This one up is 33, 34, and then a whole bunch of 35s. 35, 35. How many are there? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 6, 7. Okay, and then there's a whole bunch of 36s. And so you write down your list. You rank them from smallest to largest. Again, just using the stem leaf plot as your reference. Then what you do is you add up all the terms, divide by the number of items, which is 70 in this case, and then you get the mean. It turns out that the mean actually works out to be 54.3. So the mean is located, in here somewhere. That's the mean. Now the median is located between the 35th and the 36th term. The 35th term and the 36th term. Well, let's count. 1, 2, 3, 4, 5, 6, 7, 27, 28, 29, 30, 31, 32, 33, 34, 34, 35. So 61 is the 35th term, and 36, the 36th term is 62. So I'm going to break that down. The 35th term is 61, the 36th is 62, which means that the median is the average of those two. $61.5 is the median. So question 6, the unit activity is below are 30 exam scores from a statistics exam. And you're going to enter these scores into the stem plots tool. So once again, make sure you have the document saved to a drive and have it opened in Word so you can copy and paste this data from Word into the stem plot tool. So once again, what I can do is I'm in Word. I'm going to copy this information and I'm going to paste it into the stem plot tool. So here we go. Here's the stem plot plotter. Clear the information there. I'm going to right click, then I'm going to hit paste. And there's new information. Now I'm going to generate a stem plot. And there's the stem plot. So now I'm going to do my calculations. I'm going to find the mean, the median, and the mode, or modes, if any, because you can have more than one mode. And in fact, I just want to be more specific here. The mode is the most common value. So the previous example, the modes were grouped around like they were in the 60s and in the 70s. I didn't break it down and Okay, which is the most common value in those peaks. If you can have more than 2 modes even. I'm going to write this question out because there's not that many terms, and I'm going to identify exactly where the mode or modes are. Right, so I've ranked all the scores and I've totaled them. The total of all the scores is. So I have totaled all of the scores from the stem leaf plot, and I've also ranked all the scores. The total of 2,253, there were 30 terms, so the mean actually is 75.1. And that's the mean value for the data in the stem leaf plot. To calculate the median term will be given by the n plus 1 divided by 2 formula, and the position of the median term will be between the 15th term and the 16th term. This is the 15th term. That's the 16th term. Well, in both cases, the number is 75. So the median is the average of the 15th term. That's the 15th. That's the 16th. And, well, they're both the same number, so the median is equal to 75. Now, the mode is the most common term, and in my ranked data, you can see that there are actually 5 values of 75. Okay. Interesting. 5 values of 75. And that's the mode. So the mode in this data set is the most common term, which is also 75. So this is really a symmetrical distribution, in effect, because the mean and the median are pretty much the same number. And it doesn't really matter which of the 3 descriptors you would use to determine center, because the median, the mode, and the mean are all pretty much the same number. So now you do the exercises in Unit 4 yourself. So you could, some of these questions you could choose to answer with a histogram or a stem leaf plot. And if you do need to actually download any data, large amounts of data, and you want to put that data into, say, the histogram plotter or a spreadsheet, make sure that you save the document, Unit 4, as a PDF to your drive, and then open it up in Word so you can capture the data. That's it.